So in this video, we're going to talk about the continue, break, and also else, which I know we have talked about a little bit in the past. Talk about those three keywords. Now, when you're actually coding, sometimes you may need to interrupt the normal flow of a loop to either jump out of it completely or to stop the current iteration and move on to the next. Now, once again, in this example, I'm going to actually show you how to do that. We're going to use a list, even though we haven't actually covered what lists are yet. So hopefully you can see that we're just using them as a sequence of strings, but don't worry because we're going to be taking a good look at what lists are in a later video. Let's just type up a little bit of code to get started. I'm going to type shopping list equals milk, pasta, eggs, spam, bread, rice. That's a list of strings effectively, as you can see there. And we could do something like for item, which you've seen this before, in shopping list, colon, print by plus item. And you've probably seen similar code to this. We have seen similar code to this. If we actually run it, we get it going through each item in the list and actually printing out the word by plus whatever the item is in the list over here on the right hand side. Now that's simple enough, but in true Monty Python fashion, we don't like spam. So we could check for the current item not being spam, and before that, before actually printing the reminder. But in a loop with a lot of processing, it can often be preferable to just skip the item we don't want. So this is what continue lets us do. So what we can do is actually put an if test in there. So we can come in here and we can put if item is equal to the two equal signs, because we're trying to compare to see whether an item's simple, it is equal or not, as opposed to an assignment operator. So if it equals spam, we type continue, getting our indent levels correct, and otherwise we're just going to leave the print in there. So you can see what should happen. Going through the list, if it finds an item with the name of spam, it's going to continue, and we'll see what that does shortly. But failing that, it's actually just going to print out the items as it was doing before. So now if I actually run this, you can see that we've still got all this, all the output we had before, but one thing's missing. You can see what happened was spam is now missing from the list. So what happens is continue actually stops processing any more lines in the block and forces the for loop to move on to the next value in the sequence. So in other words, what happened was it got to spam, realized that there was a match there, so I looked at that line. When it found that it was equal to spam, continue effectively bypassed this altogether, so it didn't actually process line 6. It went back to line 2 and moved on to the next line. So you can see there that we were at eggs, which is the item before spam, and we conveniently bypassed that and went straight on to bread. So that's what continue does. It actually bypasses, or actually stops processing for that particular block of code and forces the for loop again to move on to the next value in the sequence. And again, it's very important just to note, which I'm going to harp on throughout this course, be very careful with your indenting here. As always, the call to print is indented to be at the same level as if, so it's not part of the block code controlled by if. So again, if we move this over here, we're going to get a different result. In this case, we're getting no output at all, which is probably very confusing for you. So make sure you're in the same level, because what we want to do is we want to print basically each iteration of the loop, and it's only if it hits continue that we actually go back to that item. And just as an aside, we could have done something like this. We could have actually printed a message here to say print I'm ignoring plus item. And because it's at the same intent level, if we run that, by milk, by pasta, by eggs, I'm ignoring spam, by bread, by rice. So you can see we could have actually added that at that indent level if we wanted to. Now, a similar statement to continue is the break. So it's possible to break out of a for loop completely using the break command. So if we actually replace continue with break, we'll not get a reminder to buy bread or rice, because the loop's going to terminate when it gets to spam. So let's just see the difference there. So we just run this again without my extra print line, and you can see we've got the 5 items there with no spam. But if we change change continue to break, like so, if you run it, you can see the result we've actually got there. So we've actually got nothing after eggs. So as soon as it hit spam, there was a match to that, and the break then actually avoided actually processing anything else altogether. So it's probably not what we want to do here, but it's just a different way of doing it. Whereas continue will actually miss just that current item, break is essentially going to miss out on all the rest and actually exit out of the for loop and not do any further processing at all. So in this particular case, it's probably not what we want to do here, because if we're ordering a meal and we wanted something without spam, we could search the list for an item. That would be another way of doing it. And obviously we want to stop looking if we found it. So let's just go through and actually type in that example. I'm going to leave that first example as it is, but I'll actually comment it out. So let's do another scenario. So it's meal equals egg, bacon, spam, sausages, like so. We could put for item in meal, and you've seen that before, processing going through a list. And if item is equal to spam, two equal signs again, then what we could do is we could put nasty food underscore item equals item and break. Then we can come back here and put if nasty food item print can't I have anything without spam in it. So if we actually run that, can't I have anything without spam in it? And that's because we actually found spam in the list. So in that particular example, we could allow the loop to run through all the items and it would still work. And we could comment out the break line to confirm that. So if we actually commented that out, we do get exactly the same result, but in this case, it's not actually breaking out of the loop this time. Basically, it's a good idea to do that. So again, if you had something with, a search with thousands of records here, let's just say this entry for meal was thousands of items, we could actually go through and finish it and go right through the entire loop and without breaking. So in other words, it would match the first item and then continue processing the rest. But in this case, it's smart to use break because what we're doing is as soon as we find the first match for the word spam, we're immediately exiting the for loop and we're not doing any further processing. So again, we're being smart with the utilization of hardware of our computer and not processing any more than we actually need to. So break's very useful in situations like that where we want to terminate a loop earlier when some condition is met. Now, with that said, there's a serious actual problem with the program above. Now, did you actually spot that? See if you can spot it without actually running the program again. And the hint to look for is what would happen if there's no spam in the list. So did you spot it? Well, if you remove spam from the list, you're actually going to get an error. So let's just do that. We'll call that tomato and run it. We actually get an error. And you can see the error is nasty underscore food item is not defined. And the error that it's crashing on is actually line 15 when it's trying to do this test here. And if we actually have a look, we should be able to see line 15. It says line 15 over here. So it's crashing because we didn't find an item with the name spam, nasty underscore food underscore item was never set to a value. So at first glance, if looking at it, you might think that you can rewrite this line and change something like this. So if nasty food item is equal to spam, that might help. But it doesn't actually make any difference in the scheme of things because nasty underscore food underscore item has never been defined because ultimately spam was never found in the list here. Now, if you actually look carefully in IntelliJ, it's a little bit harder to see on my screen, but it should be a little bit easier for you. At the far right of line 15, and actually hovering, if you hover over it, you can see a warning. And if you actually just hover over it and have a look, name nasty underscore food item cannot be defined. So unless you get a green tick at the top right-hand corner of your code editing window in IntelliJ, it's likely there's a problem in your code somewhere. And it's actually a good idea to investigate every one of those warnings to see what they are. And ideally, you should be able to resolve pretty well all of them before you actually run your code because they're there as a warning to tell you that probably what you've done is you've you've made a mistake in your source code somewhere. And it may not be enough of a mistake to have caused an error, to actually highlighting an error. It may not crash your program, but it is actually IntelliJ's way to come back to you to say that this is something you need to relook at. So how do we go ahead and actually cure this problem? So the cure here is to make sure that we initialize our variables to a value before we start the loop. Because what you can see is in here, nasty food item is only ever initialized for the first time when we're actually in that loop. And in this case, if we actually find the item spam. So what we actually should have done is actually initialize this up here. So just under meal, we could put nasty underscore food item and put 2 quotes there to initialize it for the first time. And then we should find that this is actually going to work for us. And the reason it's going to work is because no matter what, nasty underscore food underscore item has now been initialized on line 10. So if we run this, now we get no output, and the reason we get no output at the moment is because remember I changed spam to tomato, but notice there's no errors anymore. And if we put our little cursor over here, we've got 4 weak warnings, but no major warning here. So that's a sign that everything's okay. And you can see some of the warnings are quite minor, like it's saying, so I hovered over this one on line 17, no new line at the end of file, missing white space after comma. So what it's actually saying there is it really wants us to actually put a space there for those. And notice how that disappeared when I actually did that. So it does actually make sense to actually read these warnings and see if you can actually resolve them. So what that probably wants us is to press enter like that. And notice how it added 1 extra blank line at the end, and that actually made it happy. So again, pay attention to the warnings that IntelliJ is popping up for you, because they're normally there for a reason. They're there to guide you and ultimately to make you a better programmer by helping you find common errors that are actually, programmers actually put into the code by mistake. Okay, so we looked at break and continue, and we've actually seen else when we looked at testing conditions using if, but we can also use else at the end of loops. And probably the way that it's been defined, it's an unfortunate word to use else for what it does with loops, because its use doesn't really imply otherwise in any sense. What it does, it causes a block to be executed if the loop was allowed to continue to the end. In other words, if the loop was not broken out of. We can demonstrate that again. And just before I do that, just to confirm that this code was going to work, I'll change it back to spam and we'll run it again. Can I have anything without spam in it? So you can see that did work. I want you to also pay attention to the little green arrow in the top right hand corner now. We actually fixed all those errors up and there's now no problems found. So in an ideal world, what you'll want to do is every time you're creating a program, you should be able to see that little green tick there to indicate that as far as IntelliJ is concerned, a lot of the basic errors that crop up have been addressed and you've actually fixed those. Still no guarantee the program won't crash, but chances are you've identified a lot of those common faults that we fixed up in this video. So let's go ahead and actually look at to see how the else works. And as I said, else works for the for loop in this case. So we can type in else. We can actually put it here. Print I'll have a plate of that, then please. We can leave everything as it was, and if we actually run it. But one problem actually still remains when we do that, is that we don't end up ordering the meal if it doesn't contain spam. So we know the meal is spam free if the loop is not broken out of, which is exactly the situation that the else was designed for. So now if we change spam to say beans, like so, and we actually run it again, I'll have a plate of that then please, and I'll actually fix my typo. So you can see the else is only going to work if the if was never actually executed. In other words, if we actually never broke out of the code. If we leave spam in, the loop does break and the else block is ignored. So you can see what's happening there. So again, if I go back, make that spam again, the else block isn't executed because we did actually break out of the code. So that's what the else is there for. And as I said, it's probably not the best name. Probably a bit of unfortunate word to use for that because its use doesn't really imply otherwise in any sense. So again, what it does, it causes the block to be executed if the loop was allowed to continue to the end. In other words, there was no break. And again, as always, be very careful with your indentations. It's particularly tricky here. It's that else can follow both an if and the for statement. So you could quite easily have put an else there and actually got a completely different result because the else is now attached to the if as opposed to attaching it to the for. So really do make sure you spend some time early on getting your indentation levels correct, or you'll actually have all sorts of weird problems happening and you'll be wondering why. And very common when you're starting out with Python to have these sorts of errors, which are basically to do with indentation levels. And incidentally, if we leave that beans in there, the else could be a good actual place to actually initialize our nasty food item. So we could have actually initialized it at that point, and that will now work. And the reason for that is the else here is only going to be called if we haven't broken out of it. And the break here is actually only breaking because we're actually looking for the word spam. So if we run this, that's another way of actually doing it as well. So that basically ensures that the variables are defined for the loop if the loop terminates normally without a break. Now, whichever is better is probably personal preference. My background's being weaned on languages like Pascal, where everything has to be declared before it's used. So for that reason, I would normally recommend you actually put the code up here. So you'd initialize it at the top, so it's clearer. And I think a lot of programmers would probably look for that as well. But again, it is a feature of Python. If you want to, you can actually define it in that else method as well. There would certainly be plenty of people who would argue with this and say that it should actually be done in the else. One thing I would say that once you've actually decided on which way you're going to do things, be consistent and do it the same way every time. That's not only going to help you when you revisit your code months later, but it's also going to help other people who read and maintain the code you've written. The other thing I want to point out that the actual variable name nasty_food_item isn't consistent with the names that we've used in the past. We've actually named our variables with what's called camel case, and that's something like nasty_food_item is not like that. We would have done something like this, nasty food item. So starting with the lowercase for the first word and then each subsequent word, we capitalize it. That's called camel case. Now, we could have done it that way, but we wanted to show that there's different conventions for variable names in Python. Now, languages like Java and C have very clear preferences that most people adopt, but Python doesn't really have a firm convention to follow in this respect. So there's no one sort of way of doing it. There's no sort of common scenario that says you should write your code this way. So again, whichever way you prefer to do it, whether you want to create a variable with words like separated by underscores, or you want to use camel case, which is the word, first word being lowercase, then each word after that capitalized with a letter to help separating the actual words. The thing here would be to actually be consistent again. And if you've come from languages like Java and C, it's probably a good idea just to follow the same conventions, just to make sure that if you are going back to those languages, you're not actually bringing these sort of habits back to them. But again, completely personal preference. Whichever way you prefer it, it's up to you. Again, I can't stress enough to make sure you're actually consistent. So we're going to be consistent within individual video topics, but we're going to actually use both styles just so you get used to them both. Just another reminder also before I end this video is that Python variables are case sensitive. So in other words, nasty food item is actually different to nasty underscore food underscore item on the first line with the lowercase n. Two totally different variables. All right, so I'm just going to delete that code there. And we're going to finish the video, or end the video here now. In the next video, we're going to actually look at augmented assignment. And I know that sounds like a mouthful, but you'll be finding out what that is and how to use it in the next video.